Hi everyone. This movie is about chaos theory and it was done by these people. So, what is chaos theory? The best way to describe it is by showing you the following example. Here we have two balls of magnet and a line drawn. If the magnet were moved on this line, the other magnet will stick to it once it gets close. The same if we get more magnet balls and a bigger magnet got to be on the line. This time the magnet balls will move each other towards the big magnet, resulting in the given result. But what if only one magnet was moved a very small distance? What could possibly happen? Well, this small change will cause a change in the movement of all the other magnets, which will result in a change in the result given. So, did you get chaos theory? Well, chaos theory is the effects of changing the slightest conditions and then observing the results. Think of it as how changing anything small and seeing the results of this small change can make the biggest of differences. These things can vary from change in wind speed to the motion of the planets in their orbits. The changes include anything and everything around us, from the smallest to the biggest. The first observation of these phenomena were found by Henri Poincaré, who studied the three-body problem. The study objective was to study the movement of a simplified solar system that consists of the Sun, Earth and the Moon. The three-body problem is the problem of taking the initial positions and velocities of three-point masses and solving for their subsequent motion as dictated by Newton's laws of motion and of universal gravitation. So basically the three-body problem is to solve for the motions of three bodies interacting through an inverse square force. What Poincaré found out that even this small diagram moved in an unpredictable manner, which resulted in the three-body problem being unsolvable. A mathematician was researching the possibilities of long-term weather predictions. He decided to write a computer program using mathematical equations which could theoretically predict the weather outcome. While building the program, this mathematician created a theory that will be the point of focal in chaos theory. This theory is called the butterfly effect. Butterfly effect is a simple term indicating how a butterfly flapping its wings somewhere in the world can trigger a series of events that could possibly lead to a hurricane in another part of the world. This mathematician is called Edward Lorenz. One day, he wanted to know what the weather might be in the afternoon. Instead of running the whole program designed for long-term predictions, he started from the middle of the sequence to realize that his outputs were completely different results than what he had expected. He later realized that the computer recorded the data to 6 decimal places, while he entered his data to 3 decimal places. Being derived from chaos theory, the butterfly effect simply states that a small change in any initial condition can cause major changes in the outcomes of that event. This result will lead us to the point of deterministic chaos. So what is deterministic theory? Deterministic chaos is the inevitable growth of errors that can lead to an event. Is this beautiful butterfly the reason behind a storm that might have killed people? Well, not all butterflies are the sole reason behind that. Simply we cannot find out exactly what tipped the system. There are too many factors that could have done it. What we can do though is play a chaos game. Take a piece of paper and make 3 points like such. We will label them A, B and C. Now choose a random point in the middle of those 3 points. We will just put it right here. Now all you have to do is make a point halfway between your starting point and point A. From this point make a point halfway between here and point B. Repeat the process for point C and continue this pattern rotating between point B and C. If you do this long enough, you will see something interesting start to happen. As more and more generations of points are drawn, an image starts to emerge from seemingly random points drawn from chaos, from disorder. This complexity and orderly figure shows its face. From drawing a few points and following certain rules, chaos can form order. It's a fractal, They are infinitely complex patterns that are self-similar across any scale. This shows that with enough time, random actions can have serious long-term effects. So, in the end, this beautiful butterfly did not call upon the storm itself. Think of it as Jenga. Take away a certain block and things can be just fine. But one block, that one special block, if removed, causes everything else to fall apart. In the 1970s, Benoit Mandelbrot, the famous Polish-French mathematician, edited Fractals of Chaos Theory. By creating Mandelbrot's set of fractals, one can predict the pattern of coastlines and clouds no matter how close or far they can go. There is always a pattern. These designs show Mandelbrot sets that was created in the chaos game, but of course these ones are done by a computer. These fractals will keep creating shapes of self-similar images when zooming in from 10 scopes to 10 to the power of 277 scope. Fractals are calculated by mathematical equations that form these patterns and shapes. The fractal is built on the equation Zn plus 1 equals Cn squared plus C. As we go more into the topic, we realized how deep changes from small particles can affect the bigger ones. These effects do not just include nature, but they also include real-life situations in our life. The truth is that this is how ecosystems, human societies, and even the stock market behaves. During the Cuban Missile Crisis, a Russian nuclear-armed submarine was stationed off the coast of Cuba. American ships detected the submarine and began using depth charges to signal that the submarine should surface. However, the submarine's crew mistook these depth charges for bombs. The Russian captain believed that war had broken between the United States and the Soviet Union and ordered a nuclear torpedo to be sent immediately. Everyone agreed except for one officer that no action should be taken, and thus World War III was prevented. Not until later time, it was proven that there is a chaotic behavior in the motion of asteroids. Pluto, as a body orbiting the Sun, is quite interesting. It takes nearly 250 years to revolve around the Sun. When Pluto movements were studied, the motion were found to be chaotic. What this means in practice is that if we change the position of Pluto by 1 millimeter, then in 100 million years, it will be on the opposite side of the Sun. In some cases, Mercury, for example, developed such a significant chaotic behavior that it collided with Venus, which proves that chaotic behavior may lead to instability of the planetary system. Jacques Lasker was inspired then to study the evolution of the whole solar system, using equations of motion to find out that the whole solar system evolves chaotically. Though the planets have been stable when historically observed, and will be in the short term, their weak gravitational effects on one another can add up in unpredictable ways. For this reason, among others, the solar system is chaotic, and even the most precise long-term models for the orbital motion of the solar system are not valid over more than a few tens of millions of years. No matter what orbits did the planets choose, changes will always happen due to chaotic behavior.